Did you know that your eye is a remote sensor? That's right. Eyesight is a form of remote sensing. When the eye sees an object, the electromagnetic radiation, which is reflected light, from the surface of that object is registered by your eye. The radiation contains information about the surface, but we tend to see it in form of color and the form of the surface. Now our eyes have what we call photoreceptors. These are specialized light detecting cells that lie back on the retina of your eye. Humans have two photoreceptors, the rods and the cones. The rods are those cells that detect dim light, and so they do require areas that have dim light. For example, night. So we use the rods to see during the night. On the other hand, your cones are the cells that detect different colors. And in this illustration, we see the cones as green, red, and blue. Now your cones work in environments that are bright and well lit, and they help us differentiate between different objects based on their colors, especially during daytime. So yes, your eye is a remote sensor. The other common remote sensing device that I can talk about is your camera. When you take out your camera and imagine if you turn on the flash option, it sends out a signal to an object that you're trying to take a photograph of, and then that object will reflect back certain radiation. That's what is recorded by the camera. Compared to the eye, a camera that uses flashlight is called an active sensor because it relies on its own source of energy, the flashlight that sends out. Whereas the eye relies on ambient sources of energy. So we rely on the energy from the sun during the day to be able to look at different objects and be able to differentiate between them. So your eye in that case is a passive sensor because it relies on another source of energy. So what is remote sensing? Remote sensing is the science and art of taking measurements and observations of something that whatever is taking those measurements is not in physical contact with. So that's why I say your eye is a remote sensor. You are able to see away from the eye, see something and make sense of it using your photoreceptors. Now in remote sensing, there are some things that are of importance. We need to have an energy source, so in this case the sun. Now that energy is allowed to pass through the atmosphere towards the Earth's surface where we have the objects of interest, including buildings, roads, vehicles, grass, water, and forests, name it. But as this energy goes through the atmosphere, depending on the characteristics of the atmosphere, for example, if you have a day where you have a lot of, particulate matter in the atmosphere, aerosols, clouds, these will affect the radiation that's coming from the sun. And so part of it will be reflected within the atmosphere or absorbed. So bottom line, you do not get the same amount of radiation you got from the sun coming to the Earth's surface. Now at the surface of the Earth, you have these different objects. Each of them has differences in characteristics depending on the material of the object. Some of them will reflect more radiation, others will absorb more and emit more. And so depending on the material of the object of interest, our satellite sensors, for example, will record those differences. So grass, for example, will not reflect the same way as water. If you have an area that has snow, that reflects more radiation than an area that has water. So water tends to absorb more radiation and reflect less. And so those differences in reflection, absorption, and emission from these different Earth surface materials as recorded by our sensors will help us differentiate between the surface materials that we have. Remote sensing is a process, and like I mentioned, we require an energy source, which can be from the sun, or it can be active, which is a sensor that sends out its own signal. If you've heard about sensors like LiDAR or radar, I just gave an example of your camera. Those we call active sensors because they send out their own source, like their own energy or radiation, and then detect what the object that interacts with that energy reflects back. Anything that relies on the sun, we call that a passive sensor, and many of the satellites actually are passive sensors. But we do have a number of satellites systems that are also active sensors. We need to have a target. So think about that object of interest that you want to take measurements of. Now, when energy interacts with the target, depending on its characteristics, will reflect or absorb it and emit, and whatever is coming from the target is what is recorded by your sensor. And then the sensor sends out that information to a processing station where the data is processed. Now, processing involves us removing atmospheric effects, involves us taking care of any errors that might have arisen during the process of data collection. And now after cleaning that data, we have a data set that we can analyze. So you are at this point of analysis, make meaningful information out of the data, and then we can apply that information to solve a problem that we might have. So for example, if you have a sensor that is able to record flooding and give you information about inundated area, you can analyze that and calculate the total area that's been inundated, but also probably put that data in GIS to see it in space, and then that information can be used to make decisions about how to deal with the flooding and guide resources, emergency resources and many other things. So that's the process of remote sensing. And so you can imagine every now and then many sensors are being developed depending on the interest of humanity. If we have something that arises right now and it requires us to take measurements of it, especially if it affects a global scale, then a new satellite sensor can be built. For example, if you're interested, we have a sensor that was recently developed a few years back to monitor soil moisture across the globe. And so sensors are being built every now and then. So I want you to check out a website that shows the currently orbiting satellites around the Earth. So NASA does a very good job in demonstrating that in form of an animation. So when you click on this link, it should take you to this page that you see right here, and this page that is showing you the different satellites that are available as we speak right now. So you can check satellites now, and you can see where they are in orbit as we speak right now. And so each of them has its own orbit and path that it will take. There's Landsat 8 here, so you can click on it to see how it looks like, in terms of shape. And that's Landsat, and it is right at this point taking observations at that point of the Earth right now. You can compare its size with the scientists, for example, so see how small we are compared to this satellite. You can compare it with the school bus and see how small it is compared to school bus. And here I can go back. So I'll encourage you to, just explore this website and look at the different satellites, and even look at the different variables here in terms of observations. So I can click on air temperature just to see how the air temperature looks like, and you could create a time lapse. So time lapse of air temperature, just see how it has varied through time as taken by, the different satellites. So these are scenes. You can see these blobs of, areas that are scenes that are taken by a given satellite. So I'd encourage you to really check this out and just have fun with it. Okay. All right. So with that, I would like to say that is it for today, and I hope I was able to introduce remote sensing to you briefly. My next video will be about how to access and download remotely sensed data. So if you had fun with me today, please leave a comment, and I can't wait to see you or interact with you in my next video. Thank you.